Now that we've used linear interpolation to come up with an idea of what our spot rates are going to be, we're going to use a more accurate form called a cubic spline. So I'm just going to move our linear interpolation over here, and I'm going to change this title really quick. Okay, so we're going to need to create a new column here. We're going to call it cubic spline, and down over here. So what we're going to need to do is now we're going to introduce more parameters than just having a linear. So it's going to be kind of a quadratic function. So we can have now a value, a parameter for row, a parameter for A, a parameter for B, and a parameter for C. And what we're going to do is our formula for our cubic spline is just going to equal, well, first off, let's put some just arbitrary values in here, and let's just say that all of these are 0.5 and not percent. We just want it to just be general 0.5. I want to make that all of them. So for our cubic spline, it's going to be, our value is going to be equal to row locked plus our parameter for A locked times T, which is our year, to the third, plus our parameter B, lock that as well, times T to the second, plus C locked times T, or just T. And then we're just going to say that this is a percentage. Drag that all the way down, and as we can see, those numbers do not look accurate at all. So let's try just doing 0.05, see if that helps out at all. Okay, so obviously these are very off right now, but we will be able to get a more accurate value in just a second. So we're going to create another column called residual squared, and the key thing to note here is you can only find residuals where there is an actual rate here. So in this case, our residual is just going to be our cubic spline value minus the actual rate to the second. And the reason why we take it to the second is to is in case there's negative values, it wouldn't cancel out from positive. We just want to get like the magnitude of the difference. So then we're just going to copy and paste to all the instances where there is an actual rate. We have one more here. And at the very bottom here, we're just going to get the sum of our residuals. The sum of our residuals. So now we're going to use this new function in Excel that you might not have seen before called solver. So you're going to need to add this in. It doesn't come already in Excel. So what you do is you go to File, you're going to go to Options down here, go to Add-ins, and where it says Manage Excel Add-ins, press Go, and we're going to check right here where it says Solver Add-in. So press OK. So now when we go to the data ribbon up here, we see that there's this solver added up here. So now what we're going to do is we're going to use our solver, and we're going to set our objective cell to the sum of our residual squared. And we're going to want to get it to a minimum by changing our parameters of row A, B, and C. So now make sure you unclick this button. We do want to allow our values to be negative. So now we'll press solve. And let's see, we're probably going to need to run that one more time. And so now we'll make sure that these come up. We'll do them to 2 percentage points. So now we can graph our, and as you see, every time we run solver, our parameters automatically change to optimize our estimates. So now we're going to graph our cubic spline, our actual, oops, forgot to hold down control that time. So again, you got to make sure you're holding down control when you're trying to do multiple columns. So we're going to get our actual rates and then also our year. Alt ND, and we're going to do scatter with smooth lines. And again, we're going to go right click. We're going to press Format Data Series right here to Marker. Let's see, or sorry, Fill Options. Go to Marker, Marker Options, None. And as we can see, we now have our actual rates are the blue dots, and our cubic spline is our orange. So let's add axis titles. This is rate. And at the bottom we'll have maturity. And we'll call this cubic spline. Now we're also going to add in a trend line then here, so just press that plus button, click trend line, and we want to do it for our cubic spline. Let's see. Let me make some edits to this real quick. So format our trend line. We want to make sure this is a polynomial to the order of 3. And let's see, let's change our fill options. Let's make it black. And there we can see that our trend line follows our cubic spline. After doing the cubic spline, we're now going to try another method called the Nelson-Siegel method. So I'm going to move this here. So these were our parameters for our cubic spline. Now we're going to want to make another table for our Nelson-Siegel parameters. So we'll have beta 0, beta 1, beta 2, and tau. And again, we're just going to put some arbitrary values to begin with. So let's just do 0.05 for all of those now. So this will be our Nelson-Siegel. And now we're just going to copy or write this equation into Excel. So it's going to be equal to beta 0. We're going to make sure we lock all our parameter values plus beta 1, lock that, times, and now we're going to need to make a parentheses. We're going to do double parentheses 1 minus exponent of negative RT, which is our year, divided by our parameter for tau. We need to lock tau. Close that up. Divided by RT again, divided by tau. And lock our tau. Plus beta 2, lock that, times 1 minus exponent, we're using the exp function, negative t, divided by tau. We're going to lock tau again. Okay. Divided by RT divided by tau, making sure we're locking tau, minus, let's see, so we're actually going to need to add one more parentheses in here. Sorry, this one's pretty jumbled up, so, and then we're going to do minus exponent again, negative t divided by tau, and lock tau. Then we close that all up, and there's our value for our Nelson-Siegel. So we'll drag that all the way down, and we're going to want to make these percentage to 2 decimal points, and just like we did for the cubic spline, we're going to make a column for our residual squared, and that's just going to be our Nelson-Siegel value minus our actual rate raised to the second. And again, we can only copy and paste that for entries where there is a value for the actual rate. So I can just go ahead and start copy and pasting this down and just double check that it's doing everything correctly. Let's see. Just keep doing it all the way down. H64. Okay, perfect. So now we're going to do the same thing that we did in our cubic spline method, in that we're going to use our solver, but a key thing to note here is for solver to work accurately, your parameters need to be somewhat close to what a realistic value of them is. So for this particular example, we're going to make all our parameters 2 to start out with. So now we're ready to go, so we'll go into our solver. So we're going to set our sum of our residual as our objective, and we're going to make it to a minimum by changing, let's see, our parameters. So make sure that this is unclicked, and then we'll run solver again. And now we see that we have, change this percentage. Now we see that we have done, well, we have values that are similar to what our rates are. So we're going to graph this again. So we're going to graph our actual rates and our year against our year. So Alt-ND, scatter with smooth lines, and we're going to format our Nelson-Siegel. So we want to make sure that our marker is not filled in. And now you can see, you know, where our Nelson-Siegel curve shows us what the rate should be. So now we can add our axis titles, and as well as name it. So this is our Nelson-Siegel. Our x-axis is maturity, and our y-axis is our rate. So now in question number 5, you're going to kind of discuss which of the 3 methods you think gives you the most accurate representation of what your spot rate curve should be. And then you're going to list some of the pros and cons of each of the methods. So this was number 4. So again, for 5, we'll just insert a text box, and you can write your answer.